My topic this morning is on apple scab, and more specific, I will speak on disease and support systems to enable us to increase our effective management of this disease. Now, any disease and support system is based on the epidemiology of the specific pathogen. In the case of apple scab, there are three very distinctive phases in the life cycle of the fungus. The first of this is the overwintering phase, during which ascospores develop through a sexual process on dead fallen leaves on the orchard floor. The second phase is the primary infection period, during which the first formation of lesions occur based on infection by ascospores from the overwintering source. And then the third phase of the disease is the secondary infection period, following the primary period, where the inoculum source is based on asexual spores, the conidio spores. The amount of primary inoculum at the beginning of the season is based primarily on the infection present at the end of the previous season, as well as the prevailing climate during the winter period. The amount of disease at the end of the primary infection period will be based on the amount of ascospores at the beginning of the season, as well as the infection cycles that occurred and the efficiency of the management systems that was employed. And then the amount of disease at the end of the secondary cycle obviously will be based on the amount of primary lesions that was established during the first part of the cycle, as well as the success of the management efforts during this phase and the prevailing weather conditions. Now, if you look at the strategy to control this disease, it will be obviously based on minimizing your carryover, your winter carryover, which will be a function of the success of sanitation measures. And then during the course of the primary and secondary infection period, the success will be dependent on the ability to adjust the timing and the choice of fungicides according to the development of the disease. Now, there are several factors that will influence our success of the management and modeling of this disease. The first of this is our ability to estimate the potential ascospore dose at the beginning of the season. This, as I've said, is obviously a function of the disease pressure at the end of the previous season, as well as the success of sanitation measures. But at the moment, we don't have the ability to do these estimations. This, however, is quite common in Europe, where they classify the scab risk for a specific season based on the amount of lesions on the leaves on shoots at the end of the previous season. And they have three categories: below, moderate, and high, also based on the susceptibility of the various cultivars. Due to limitation in time, I'm not going to expand a lot on this table any further. The second factor that has influence on our success is our ability to estimate the emergence of new leaf and flowers during the season, because obviously after the application of a chemical, 2 or 3 days later, the new leaves and flowers that emerge will not be covered and not be protected by the fungicide. And at the moment, this is also not part of our ability to proper estimate the occurrence of this. Then in the third place is the ability to estimate the amount of ascospores that will be present during a specific infection cycle. We are also not being able to do this at the moment. At present, the models that we use only look at the duration of the leaf wetness period, as well as the temperature during this period. which give an infection index, but in the process ignoring the amount of inoculum that is present during this event, which will obviously have a big impact on the amount of the disease that will develop. The fourth factor is the infection pressure as dictated by climate as well as the phenological development of especially the fruit. This we can do based on the models that was developed by Mills, further modified by Volkswagen. And you can see, based on those two graphs, that there can be quite big differences between areas in specific seasons. This was for last season. The graph on your left-hand side was in the Langkloof. The one on the right-hand side was for weather station in the Kowe-Bokkeveld. Then the last thing that we need to estimate is the loss of fungicide due to wash-off, as well as the development of new growth. And once again, this is also something that at present we are not able to estimate with the current modeling that we are using. So where do we stand at the moment? We are at the beginning of evaluating the Rumpro model, which was developed in Europe. This model will incorporate, or do incorporate, all these factors that I've referred to, which will put you in a position to better adjust the timing and choice of fungicides according to disease development. This model was developed through the input of various scientists from all over the globe over the past 30 years. This is not something that has stopped. It's an ongoing process. These guys meet on an annual basis in January, where they will sit down, look at any new research, and where appropriate, we'll build it into the Rumpro model. And a new version of this model will be available early next year. If you look at this model, this is basically what you will see. If you go to the computer screen, as jy kyk hierso aan op die heel onderkant, die donkerblou areas, dui 'n benattingsperiode aan, ander woorde 'n nat periode wat gepaard gaan met reën. Die ligblou gedeeltes is 'n gepaardgaande blaarnatheidsperiode. Die donkerbruin gedeelte dui die hoeveelheid askespore aan wat nog nie ryp geraak het nie. It's the amount of ascospores that are still immature. The red part is your mature ascospores. So obviously you can see here as time progresses, there's a decrease in the amount of immature spore, increase in the amount of mature ascospores. These graphs over here is the amount of ejected ascospores. So in the case of this specific graph, which was for a station in the Eastern Cape in the Langkloof, which was looked at on the 12th of September, you can see the forecast was quite a big emission of ascospores here, which consequently will lead to quite a big infection event, a lot of disease development. The white areas indicate your spore germination phase, and then the orange part is a primary stroma phase. That's a phase after spore germination, while the spore are still penetrating the leaf or fruit tissue. And then obviously, there's if you look at, in terms of management, if you look at your ordinary preventative fungicides like difane, D-land, those kind of stuff, those can still be applied curatively during this white phase. And then there are certain mixtures of contact compounds that you can still apply effectively here, or then fungicides with curative properties like Dodine or stuff like Chorus. And then obviously this is based on forecast. At the beginning of that infection period, your fungicide cover will only be 40% based on this forecast, and you need at least 60% cover, depending on the ascospore pressure, to get effective disease protection. If on the other hand, the application was done on the 14th of September, which was on Monday, then at the start of that infection cycle, the fungicide cover would be 70%, which obviously will be sufficient cover, but towards the next forecasted infection event, that fungicide cover would have dropped down to about 25%, which will not be sufficient. If, on the other hand, a curative application is planned for the 17th of September, that will give a kickback effect, which will eradicate all infection that took place, and will also provide sufficient protection for the next infection cycle. And basically what the guys in Europe are doing is, if you have an orchard with a high risk, with a high predicted ascospore count, they will do both applications. Application at the beginning or just before the onset of the infection cycle, and then just another one just after the onset of the infection cycle. And the reasoning behind this is obvious. You never will get 100% control, and if you get 98% control, it is how much is the 2% that remain. If it's 2% of 10, it's one situation. If it's 10% or 2% of 1,000, it's another situation. So where do we stand at present? We have a research project going now to evaluate the RIMPRO model and to get it ready for implementation over the next 2 to 3 years. The focus areas of this research will be, in the first place, the development of techniques to accurately forecast or establish the biofix for ascospore maturation. And this is quite important, because if you're out even with about 5 days, that will have a huge impact on the forecasted event, especially in the beginning of the season. The second part will be the validation of the estimated ascospore release by means of spore traps and trap trees. And the third part will be the development of a scouting model to estimate the potential ascospore dose for the following season based on an orchard for orchard basis, so that you'll be in a position to classify your orchards in low, moderate, or high risk for the next season. And then the final phase is the semi-commercial employment of the RIMPRO model in order to evaluate the outcome. So for this purpose, we have permission to activate RIMPRO for 10 weather stations, which include stations in the Kouwe-Bokkerveld, the EG-Vivi, as well as in the Langkloof. And as illustrated by the previous graphs, this is what we have already done. So that's basically it.